still running. It's never going to stop. So while it can be dangerous, I'm not saying, I'll say avoid them. Avoid them if you can, but there are times where you have to use them. Let's get back to rectangles. I'm going to just rewrite the code honestly. Rectangle, float, height, float. Good. I want a list of them, so you make an array of type rectangle. I'll call this rectangle. Well, you're just call it rectangle. I'll make an int for how many that I want. Equal length, something like that. Or I can just call it rectangle. But then I'm going to get a little confused because these are very similar sounding. Call it rectangle size. I'll instantiate. I'll give the additional I'll initialize this. I'll initialize that list that's only been declared. Might as well give this an initial value. And then we had a for loop. Make sure we ran through them all. So if I wanted to give the starting value to every single rectangle, I need to start at 0, go all the way up to the end, and say the member of that list. So I type the list name, I type brackets to say which number of the list I want to grab. I'll say I, since I will change every execution, I can do it to every item in the list. With, do I have an error right now? I'll deal with that in a second.
When you're writing code, is it easier to fix the error first or wait till it's done?
Depends. When errors are fixed, it'll make my hinting better. But I knew I was typing anyway. I think I have an error, but I'm not sure what it is yet. Oh. So let's talk about debugging just for a quick second. Anytime you run, it says, hey, I found errors. Just go down the bottom of the screen where the error list is, and always start with the first problem. It might say you have 5,000 errors, but it could all be just based on the first thing. If you mistype something for some variable, and that variable exists 5,000 times, of course you get 5,000 errors, right? If I get rid of this, I'm going to have an error every time it tries to find height. In this case, I misspelled rectangle here. It says rectangle. And then later I said rectangle. That gave me 5 errors. They're all gone. There's just one error happening 5 times. Okay, so we have a for loop. Let's go ahead and let's start getting towards the homework. Let's give it random width and height. So now when we use random, we need to give random speed as random. I'm going to use a function called time. So, and since I use that time function, I have to include it. Include time.h. Then you can type that, and you want random numbers. Just those 2 lines. So which is random modulus 4. Modulus 4 plus 1.
So that will go to 0 to 4.
I said modulus 4 plus 1.
So 0 to 5 then.
1 to 4. Since I'm adding 1, so the random will always give you a positive number, the lowest positive number being a 0. When you do modulus, you say divide by this, and you only give me the remainder. I don't care about the division, I just want the remainder from it. If you divide something by 4, and it happens to be equally divisible by 4, what remainder would you get? What's the remainder of 4 divided by 4?
0.
0. 4 goes into 4 one time, the remainder is 0. So modulus, the lowest number modulus can give you is a 0. The highest number I can get from modulus would be a 3. If I go any higher than 3, I have a 4 again, and a 4 divided by a 4, back to the remainder 0. So modulus 4 will give me 0, 1, 2, and 3. 4 values counting from 0. If I add 1, I say take every result, add 1 to it. I get 1, 2, 3, 4. So I still have 4 numbers. The range of numbers you get is based on this, and that starting value is here. The lowest possible number.
That makes a lot more sense now. The starting value part.
So, my width and height on my rectangle can be somewhere between 1 and 4. And I'll go ahead and I will print out all the areas again. I is 0, I is plus the rectangle size, I is plus the out rectangle of I dot width times the rectangle of I dot height, and then a new line. 16, 12, 6, 8, 12, 12, 4, 16, 1, 3. Look at that 1. That means his width and height must have both been 1, if we're currently the lowest possible value. I also had a couple 16s, which are the highest possible values I could have. Do this, say, hundreds of these. Alright. Are people still confused about for loops, arrays, or structs? Do you have any questions about them? Do you want to move on? Do you want to come back to it? Sure. Everyone seems to be low energy today. Let's talk about the homework. Let's talk about what this needs to do to be the homework. What are we missing right now? What's wrong? And let's start at the top. What am I missing in my rectangle?
Coordinates?
Coordinates. I currently have a way to store a width and a height for that rectangle, but I currently have no way to store where it is. I need some kind of way to keep track of space. Here's an easy solution. Load X, load Y. And now we'll have X and Y coordinates. When I generate them all, instead of just saying random width, random height, give it a random starting point. Random I dot X equals random. Let's say 16 to 16 red. I want to be a good programmer. Instead of just writing the number 16 and the number 4, I want to make some variables for them. Say float box size equals 4. Float level size equals 16. This way, if I ever decide to change what the possible size could be, you can do that right there. Cool. Now we can give every rectangle random width, random height, random X, random Y. Here where it says +1, I'm going to get rid of that for the X and Y. I'm okay with having a rectangle existing at 0, 0. I'm cool with that. I just don't want anything that says it has 0 width. Because that would just be a straight line. So maybe it wouldn't be a rectangle anymore. Now we want to check for collisions. How do we do that? I showed you guys a formula. The formula could only compare 2 rectangles at a time. And we could have thousands, millions, billions. Who knows how many rectangles we have? But I still only know the way to compare 2 at a time. So if I only compare 2, I need to randomly pick 2 rectangles, right? So I need to compare every rectangle against every other rectangle. Let's make a quick little table, actually. Does that Excel? Yeah, it does. Excel is your friend. Let's say rectangle. Let's say I've got rectangle box 0, box 1, box 2, box 3, let's go for 5. Box 4, box 5. I need to compare these against themselves. So I'm going to write up here. Box 0, box 1, box 2, box 3, box 4, box 5. So I need to compare box 0 to box 0. Why do I need to compare box 0 to box 0? Will box 0 ever not be touching box 0? Itself. We can skip this. Skip. Box 1 needs to compare to box 1?
Skip.
Skip it. Box 2 needs to compare itself to box 2? And skip it. Box 3 needs to compare itself to box 3? Skip it. Box 4 needs to compare to box 4? I'm asking for every one. And how about box 5 and box 5? Alright. Currently, we've said box 0, skip box 0 when comparing, but it needs to then compare itself against box 1, then box 2, then box 3, then box 4, then box 5. And we'll go to box 1. We'll say compare it against box 0. Actually, look at that. We can do even better here. Box 0 doesn't need to compare against box 0. What does box 0 compare itself to after it skips box 0? Box 1. Then? So right here it says box 1 compared to box 0. Did that already happen? Yes. Box 0 and box 1 compared over here. So they line up. Box 1 doesn't even make a comparison anymore. Oh man. Look at this. Ooh-wee. If everyone else has taken a turn compared to box 5, box 5 doesn't need to compare himself to anyone. We just cut the number of comparisons in half. Look at us. Yeah, we got a plan. Cool. So box 1 will check. Then I'll check 2, 3, 4, 5, so on, so on, so on. Alright. So when we're doing these kind of comparisons, what we need is 2 for loops. I'm going to just clear that for a bit. Save it. 1 for loop for these guys. The second for loop for these guys. We're always comparing A to B, A to B, A to B, A to B, We have a new A. A to B, A to B, A to B. So the outer for loop is going to grab our A's, it's going to grab the first guy they compared, and our second for loop needs to grab all the other ones compared to. So we have a random rectangle. Generator X. Generator X? I don't know. Collision checker. Design stack or something, whatever you call it. Okay. Let's go over the formula I gave you guys. This is right here. I didn't make that extra. Okay. Let's talk about this code. And again, this was just in the homework notepad, the homework evening. We have two boxes. We have a rectangle. What is a rectangle defined by? Anyone? What else?
X and Y coordinates?
X and Y coordinates. We're working in two-dimensional space. So this same kind of collision also works in 3 dimensions. We'll just only go about 2 dimensions right now, since we don't have a 3-dimensional object yet. We got X, Y with height. Now when defining X and Y, prepare for crude SD art. Yeah, this is happening. Let me just open my page. This is Game Physics Programming 101. Short little example. Here is a rectangle. Let's pretend that this bottom left corner is 0, 0. So he's in some positive y coordinate and some positive x coordinate, right? This whole quadrant is positive numbers. Where is x and y for this rectangle? This is an open-ended question. There's no way to tell from this drawing. So even though we have a width and a height, where's x and y? It could be anywhere. For the purposes of this collision detection, I said that every object x and y should refer to the center of it, or about the center. So get to the actual center, use my drawing number. There are some engines who will put x and y coordinates in the top most leftmost corner.
Both coordinates?
What was that?
Both coordinates?
Yes. This is called a point of origin, sometimes also referred to as a pivot point. Basically, when you give this thing x and y coordinates, the rectangle needs an idea of how to draw itself around that coordinate. And we could pick any part on the rectangle to put its x and y origin point, its pivot point. This was not something you needed to know. I think I briefly discussed it, but it was okay if you didn't know it. The advantage of putting it in the center is we can write some really, well, some tiny eraser. I have no idea how to choose my eraser size. Anyway, the advantage of putting it in the middle is there's some really simple collision detection you can do if you have it in the middle. What you do is, you compare their width, their height, and their coordinates. So same data we already have. Are these two rectangles touching? No, they're not touching. Now we don't know their width, height, or their x and y. We have a vague idea. If I ask you which one of these had a higher y value, would you say rectangle 1 or rectangle 2 has a higher y value? 1. Correct. Which one has a higher x value? 2. Correct. We don't know what they are because we don't have any kind of grid here, but since I said that this was 0, 0, we know that we must be positively moving to the right of 0.
So this is on quadrant 1.
moving up. Exactly. Yes. You know your quadrants? That's exactly. And we don't need to know their x and y coordinates. We just need some formula that works for all x and y coordinates. So when your origin is at the center, there's a really fun formula you can do. You take the two x points. You subtract. You need the absolute value of that subtraction. You're trying to get the distance between them and the x. This x. And you compare that against the average width of both rectangles. Why the average width? Because this collision that we're checking for, since their distance goes from the center, we need from the center over. We only need that part, and that's half its width. From the center over, that's half this width. So if the distance between the middle points is less than half the width combined, so width plus width all over 2, both with 1 with 2, 1, 2. If the distance is less than half their combined width, they can't be touching. Sorry, they must be touching. Currently, the distance is greater than half their width. Right? Because from this point, half the width over, from this point, half the width over, they don't overlap. They don't touch. There's a line I can draw between the two of them. Now, if you check this for both x and y, if the distance in x is less than their width, and the distance in y is less than their width, you have a collision. You do the same thing again. You take the middle point. This guy's middle point. That's going to be our y distance. I'll put delta y. And if that number is greater than their combined heights, divided by 2, no collision. That's what this formula checks. We'll do a quick example of rectangles that are colliding, just so you can see the difference. Rectangle, rectangle, middle point, middle point. Their distance, their delta y, is clearly less than half this height and half this height. This one says take the absolute value of their difference in x positions. Their x differences. We need the absolute value. So this one is at, let's say, -3, and the other one's at -1. -1 minus -3. Sorry, that's a bad example. If one's at 5 and one's at 3, and we said 3 minus 5, we would have -2. And you can't be -2 distant from something. Distance has to be positive. Right? I can't say that you and I are -2 meters away. We're either 2 meters away and I'm on the left, or we're 2 meters away and I'm on the right. And we're checking just the x. So just take the absolute value. If that distance is less than width, plus width divided by 2, they must be touching. So a full collision is only when there's overlap in the x and overlap in the y. We're checking those separately. So that was a brief explanation of why to use this formula. Now let's talk about doing it. So this is where we're generating rectangles. Here's our collision checker. Now let's go back to this for a second. We need to compare every box against every other box, right? We found some exceptions we just skipped. Otherwise, we need a for loop to iterate through these, and a for loop to iterate through these. So what is the first for loop? Then we count from 0 up to what? You guys do this for every single rectangle, so how many times do I do this? Or how many rectangles I have, right? Which I'm storing in a variable called rectangle size. So I need to do it for as many rectangles as I have. So far, this is just going to iterate my rectangle. It's going to run through the list. Now I need to grab someone in that list. In fact, I'll make a variable. I'll call it rectangle A. Not a very exciting name. I keep saying I'm going to compare A to B, so let's just call the first one A. Rectangle A equals rectangle of I. So whatever number we're on, store that as rectangle A. Now, when I have a one rectangle, when I grab one, once I have a rectangle, right, these are all my A's and going across to my B's, I got to compare him to all the other ones, right? So once I have one, I do a for loop. Grab a new one. Do a for loop. Grab a new one. Do a for loop. Grab a new one. Do a for loop. You see where I'm going with this? Now, when we did this, we learned we could skip some. I will not add that yet. I'll add that. Okay, so for now, I'm just going to compare just every single one. So grab the guy at 0. Keep grabbing until you get all the way to the end. Once you've got one, do another for loop. You have to grab the second rectangle in our equation. 4. And J equals 0. J is less than the rectangle size. You got to do it for the whole list. J plus plus. All right, rectangle B will be rectangle of J. So I have an A, and I have a B. Now I need to check collision between A and B. I haven't written what the collision checking is yet, but you see why I need two for loops. Is anyone still confused about why I need two for loops? Are you guys sure? Is anyone completely lost and just doesn't know what to ask or doesn't say anything? I'm not hearing anything, so I'm going to move on. So we're running through all the rectangles, and then every time we get one of them, compare it to everyone else. Grab a new A, compare it to all the B's. Grab a new A, compare it to all the B's. I'll write the collision now between A and B. Yes. Their distance, which needs to be a positive number. The absolute value, A dot x minus B dot x, is less than or equal to, I say less than or equal to, this is kind of your own choice. If you want boxes that are perfectly touching to count as touching, or only boxes that are overlapping to count as touching. I'm saying less than or equal to, I'm saying that even if they're perfectly up against each other, I want them to count as touching. And that's just changing this or not. If the distance between them is less than their width divided by 2, I have collision. Or at least I have overlap in the x. Do this two-dimensional object, I have to also check for overlap in the y. If that's the value, A dot y minus B dot y. Oh my goodness, I'm not face there. Is less than or equal to B, or A dot height, since I'm comparing their y dimensions now, plus B dot height.
I have one question.
Yes, that's right.
How does rectangle J know that it's a different rectangle, though?
Good question. These for loops are happening at different times. They're counting differently. When we get to the first for loop, the first value of rectangle A is going to be this rectangle I, and I is equal to what on the first run? 0. I start to 0, correct? Now, right after this statement, what happens? There's a for loop. The for loop starts counting at what?
0.
0. So the first time, rectangle I and rectangle J are the same rectangle, right? That's because in our spreadsheet, when we first did this, let me save it somewhere. When we first did this, we said 0 to 0, 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 5. Then 1 to 0, 1 to 1, 1 to 2,